Good morning, students. So in the last class we started with the different classes of an operating system, and we have seen three different operating systems. One is batch processing systems. Next, second one was, what was the second one? Uh, we have seen only one, I think, that is batch processing system. And we have seen the half of the second kind of operating system, that is real-time operating system, and we have already discussed one simple example on this real-time operating system. So as per the definition of real-time operating system, it's a program that responds to an activities in an external system within a maximum time determined by the external system, right? So whatever control operations or whatever operations a computer system is performing, that has to be performed within the maximum time given to that program or a process. So we have seen one example of a satellite system, where satellite is going to send a number of digitized samples, and the computer system, which is located in a base station or a ground station, that has to collect all those samples, and that has to be those have to be stored in one of the memory, right? So that collecting and storing of a data in a memory, that has to be performed within a given time, right? So let us say we have taken an example of let us say satellite is sending 500 samples, and the time limit of a base station or a ground station to collect them and to store them in a disk is 500 1 upon 500, right? Because in 1 second it is collecting 500 samples, so one sample is collected in 2 milliseconds, right? So within that time interval, within that time limit, the ground station has to perform two things. It has to collect and it has to be stored in one of the memory within 2 milliseconds. If it takes more than 2 milliseconds, then the next incoming data or incoming bit will wipe out the previous bit, and we may lose some information, right? So the ground station or the operating system, which is located in a computer system, right? So that has to perform this collection as well as the storing of the data within a particular or a maximum time limit, right? So that is a real-time operating system. Okay, next, moving to the next slide, we will see some more examples of real-time operating systems are on the missile guidance, right? So within the time limit, the missile has to be launched, otherwise the enemy is going to destroy our missile or our security places, right? And command and control applications like air traffic control, data sampling and data acquisition systems like display systems in automobiles, right? So in automobiles also, the speedometer, what you can say, right? So it has to perform the operations in a timely manner, right? And even in aeroplanes, air traffic controls, right? So whenever the button is pressed, the parachute has to be released, or the oxygen mask has to be released during some chaos things in that is aeroplanes, right? So these all operating systems or the computer systems will follow a real-time operating system, where the task has to be performed within a given time limit, right? So let us say what are the essential features of a real-time operating system, right? Later we will see what are the different kinds of real-time operating system. Okay, the first feature is concurrency within an application. What is concurrency? Concurrency is nothing but a parallelism, right? So if given a system, if suppose a given system is made up of a number of subsystems, right? So each of these subsystem has to perform the given task to them. Each subsystem has to perform a given task within a time limit, right? So then only I can say the entire system will perform some task or some job within a given time, right? So concurrency within an application, that means programmer can indicate that some parts of the application should be executed concurrently with one another, right? So let us say a system is divided into number of subsystems, and if these all subsystems are independent to each other, right, or one of the result is not going to be depend on the other subsystem result, in that case the operating system or the user can execute such subsystems in parallel, that is nothing but the concurrency. Okay, the OS considers the execution of each such part as a process. Here, the operating system will consider each subsystem as a process, and it will execute each process concurrently or parallelly, right? Because the entire system has to finish the given task in a given time or a time limit, right? For that, we need to, or operating system need to process all these programs, or you can say execute the different processes concurrently. The second feature is process priorities. A programmer can assign priorities to the processes, right? So because the critical process has to be given a highest priority. What is a priority here? Priority is a what you can say, it is a tie between two processes. Let us say process P1 process P1 wants a CPU for some time, and process P2 also wants a CPU at some time, right? So if let us say process P1 and process P2, they want CPU at the same time, right? So I cannot assign CPU to two different processes, right? So in that case, what user will do, user can identify the criticality of these processes. If P1 is very much critical compared to P2, then he can assign a highest priority to P1, and along with that a CPU can be assigned to a highest priority processes, right? So depending on the criticality of these processes, the priorities can be assigned to different processes, and CPU will be finally allocated to one of the highest priority process. Once the highest priority process is finishes its execution, then the lower priority process can be or CPU can be given to a lower priority processes, right? So that is process priority. Sometimes a kernel or part of the operating system itself assigns priorities to what the user programs or processes. Next one is scheduling. As I already discussed, scheduling is a process of assigning a CPU to the different processes for certain amount of time is called scheduling. The OS uses priority based or deadline aware scheduling. Deadline aware scheduling comes in a real-time application itself, right? So depending on that, if process P1 is a deadline aware process or a highest priority process, then CPU has to be scheduled to that particular process first. Later it will be scheduled to some other processes, right? So that is the scheduling. Next, domain specific events or interrupts. A programmer can define special situations within the external system as events, associate interrupts with them, and specify event handling action for them, right? A programmer can define special situations within the external system. A domain specific events, again, these are the different terms which are used with the systems, right? So here he'll say a priority, right? So here he'll say the interrupts, right? So again, the highest priority processes are given as a highest interrupts, you can say higher interrupts, right? So those processes can interrupt the CPU or operating system, and scheduling will be done to those highest priority processes, right? Next, predictability. Predictability means guessing. Policies and the overhead of the OS should be predictable, right? So overhead of the OS, that has to be predictable by the user, right? Next, the last one, the reliability. The last feature of the real-time operating system is reliability. So what do you mean by reliability? The OS ensures that an application can continue to function even when faults occur in the computer. Even when faults occur in the computer, the OS ensures that application can continue to function. Application which you are running on the operating system or any of the central processing unit, that has to be continued, right? So it has to be taken care by the operating system even when the user requires certain resources, right? So if the particular resource has some problem, then OS must ensure that the user process should not be halt. So it should be continuously running by, for that case in that case the operating system has to maintain some extra resources, right? So those extra resources should be assigned to the user processes so that the user processes cannot be halted. Okay, so these are the different features of a real-time operating system. So in next slide we will see what are the different kinds of real-time operating systems, right? So there are two types of real-time systems. One is a hard real-time system, second one is soft real-time systems, right? So here instead of making them as a point, I made those points in the form of a table, right? So sometimes in the exam they'll ask what are the differences between hard real-time and soft real-time systems, right? So for that reason I had made like this a table, right? So first, what is a hard real-time system? It's a real-time system or a real-time operating system which is typically dedicated to processing a real-time applications, right? So hard means that the processes need to be terminated, or certain actions need to be taken within a given time. Strictly, the strict time stamp or time limit is followed in case of hard real-time systems, and in second case soft real-time systems makes the best effort to meet the response requirement. So here there is no strict action, or strict action needs to be taken within a given time, even if that time limit expires, right? So even such cases the system will not be destroyed, right? In such cases you can say the time limit is not strictly followed here in case of soft real-time system. Second, meets the response requirement of an application. It is going to meet, a hard real-time operating system is going to meet the requirement of an application. But in case of soft real-time systems, it may meet, because it is going to make the best effort to meet the response requirement. It is I cannot say the soft real-time systems are going to perform 100%, right? So it is making its best effort to meet the response requirement. Even that response requirement is not met, then I can say the system cannot be destroyed, right? But in case of hard real-time systems, it has to follow a strict time limit. If it doesn't meet its response requirement, then the system may be failed. System will get failed, right? So here the second difference in case of soft real-time system, no guarantee that it will be able to meet the requirement. Even if it doesn't be, even if the system doesn't meet the requirement within a given time, then also the system cannot be failed, right? So even it can meet that response requirement after a certain time, you can say. There is no time limit in case of soft real-time systems. And the third one, what are the different examples of a hard real-time system? One is guidance and control applications fail if they cannot meet the response requirement. As I already discussed, the satellite example, where ground station is going to collect the information and store them within 2 milliseconds. If that 2 milliseconds time limit is not maintained properly, then the incoming data may wipe out the previous collected data. In such cases we lose some of the information which is sent by the satellite, right? So in soft real-time systems, multimedia applications and applications like reservation, banking do not have a notion of failure, right? So let us say you are talking on a phone, let us say you are talking on a WhatsApp, right? So that can be considered as you made a video call using WhatsApp, and if you are talking to your friend, then sometimes what happens, sometimes the connection fails, right? So in that case I cannot say the call is disconnected, right? So only temporarily that connection fails, and once the connection establishes, then again you can continue talk with your what friend, right? So in that case, in such cases I cannot say the mobile destroys or the call disconnects sometimes, right? So even there will be a time gap, right? Even you may lose some kind of data there, but I cannot say the system is completely destroys, right? So in case of soft real-time systems, right? So even in case of reservation, if network fails, if internet fails, right? If you are making a reservation and if internet fails, then I cannot say later you cannot make a reservation. Later also you can make the reservation once the internet comes back, right? So these are the some examples of soft real-time systems and hard real-time systems, and these are the differences between those two. So in the next slide we will so this is the end of a second operating system, that is real-time operating system. And in the third one is a distributed operating system. As the name itself tells, distributed means the operating system should distribute the processes to different computer systems, right? In case of distributed operating system, it can be compared with the centralized operating system, where only centralized operating system is there, and if you are performing any task with respect to that centralized operating system, then operating system must always run 24/7. Then only all the user requests will be fulfilled properly. Let us say if a Google server is a centralized process, right? Server is a centralized process. The OS running in the server has to execute the user requests continuously 24/7. If that Google server gets down, then if Google server is down, then you cannot access anything from the internet, right? So in that case I can say the centralized system fails, right? But that can be compared with the distributed operating system. The centralized system has a drawback of failure. Once the centralized system fails, then I cannot access anything on the internet, right? For example, Google server itself, right? So but if I distribute that work of a Google server to some more servers, then I can say such systems are called as distributed systems, right? So instead of maintaining everything centralized at one place, I'll distribute the different works throughout the internet, right? So if I maintain three servers more, Google servers more, then if one server fails, then I can get connect to second server or third server, then I can make a request to the Google, right? So that is the part of a distributed operating system, right? So in distributed operating system, we need connection. We need computers needs to be connected to one or the other, right? So in distributed computer system consists of several individual computer systems connected through a network, right? So the different computer systems are connected through an internet, and all those computers will be going to maintain certain resources, right? So each and every computer system will maintain a resources, and when multiple number of computer systems are connected, then I'll be available with, or the resource will be available, more number of resources will be available for the user, right? So let us say one of the computer system fails to allocate the resources, then I can request some other computer system to allocate the resources, right? So in that is only possible when multiple numbers of computer systems are connected through an internet, right? Thus many resources of a kind, example, many memories, CPUs and IO devices exist in a distributed system, right? So in case of a single computer system, I'll be having a limited number of CPUs, IOs and memories, right? So when I connect multiple number of computer system through a network, then I will be having I can access multiple number of IO devices which are available in different computer systems, right? So what is the motivation? here the motivation of distributed operating system is resource sharing, has been traditional motivation for distributed operating system. The only aim of a distributed operating system is resource sharing. I can share the different number of resources for our processes. Okay.